Um, so, like we said, I'm Neela. This is Liz.
Thank you. Hi, everyone.
We have one microphone, so you guys see us passing it back and forth a little bit. Um, so we want to just give y'all a brief overview on power analysis. We're going to be specifically focusing on G-Power as it's a free, readily available resource that's very common for a lot of group level statistical tests. We're going to go through a lot of concrete examples. We're going to touch briefly on R and PASS, but we have a lot of resources built into the slides for those that we're not going to go over. We've tried to design this talk so that you don't have to memorize everything or take furious notes. We're going to have all these slides readily available online, and we try to set them up so that they are very information heavy, so they can be a very good resource for you in a year from now, in 2 years from now, when you don't still hear our voices echoing in your heads. Um, and so if there's questions throughout it, y'all can feel free to, whatever you're most comfortable with, raise your hand. We'll also be stopping for questions. You can shout questions out. Folks in the chat, we are also more than happy. We're trying to monitor it at the same time as well. So we'll try and keep all of those moving. Okay, we're using my teacher voice. It's a little louder now. And if my voice is too loud at any point, someone please signal to me. So I think we will get started. All right, there we go. So just a quick outline of what we're going to be doing today. We're going to start with all the resources that we're going to cover just to kind of bombard you with information so that you know what to expect should folks need to leave early. We're going to go over basic definitions of power analyses. What are all the inputs that you might be using in G-Power? Why are we doing power analyses? We're going to talk about when and how you use them. And then we're going to dig really deeply into G-Power. What are you putting into it? What kind of numbers are you getting out of it? And how do you interpret it? And then we're going to, again, briefly touch on the past software and R, but there are a lot of YouTube videos and links in here that we're not going to cover should you need those resources. Then we're going to talk about how do you report this? Okay, I got a number out of G-Power. What do I do with it? What is the wording? And we give exact templates that you can use. And then we're going to talk about what to do when power analyses start to get very complicated. And then if we have time, we will end with some tangible examples in G-Power. If folks here or online do not already have G-Power, you can take this time real quick to download it. It is completely free, even outside of the university. It might be nice to follow along with it, especially when we get to some of those examples. All right. So we wanted to take a second, especially since y'all are going to have some examples that you're able to work through, just to introduce yourselves to the folks around you, just to build community around some of the statistics that can get really complicated. Folks on Zoom will have a small pause. Okay. It's social psychologists. What do you expect? You have to be social. Yes. Yes. Um, Now, so we want to understand what type of information y'all are coming in with. So who has conducted a power analysis before in class or for your own research? Okay. I see some raised hands, but a lot of y'all have it completely new. We're trying to do this from the ground up so that if you have no background in power analyses, you should be able to walk away with this with some better understanding. This does assume some background in statistics, so knowing like what a t-test is, what a type 1 or type 2 error is, things like that, but we also have those definitions as well. So let's go through some basic definitions. Like in most statistical tests, power analyses have both null and alternative hypotheses. The null hypotheses are denoted by an HO, H0. This is sometimes also a subscript. And the alternative hypothesis is either H1 or you will also see HA as another very common denotion of the alternative hypothesis. Again, like in statistics, the null hypothesis is a statement that there is no difference between groups in terms of means or proportions, versus the alternative hypothesis is we're assuming there is some effect, there is some difference between a group, there is some sort of significant effect that we can be seeing. So, power analysis, let's talk about what power is. Power is the probability of finding an effect or the probability of accepting the alternative hypothesis if that effect truly exists, slash, if the alternative hypothesis is true. It is also the probability of correctly rejecting the null hypothesis. Power is often shown as a percentage or a proportion. So when we're talking about power, you're going to see us talking about 80% power or 95% power. Those are some pretty common benchmarks. And 80% power is equated to a 20% chance of having a type 2 error. We have definitions of type 2 errors a little bit further down the slide. Power analyses are also structured around effect sizes, and effect sizes are a quantification of the size of the differences that we can be seeing, and it shows the strength of the differences of the relationship. One way to think about it is if you had an intervention to increase test scores and students started at an 85 and they only increased to an 86 after the intervention, that's a really small effect size. Do you super care about that much of an effect size? But if they increase from an 85 to like a 92, okay, that might be a much more tangible, solid effect. So the effect size is how much of a difference are we seeing? Alpha levels are also something, it's the exact same definition that you would have gotten in a statistics class. It's the probability of a type 1 error if the null hypothesis is true. The probability of observing the effect solely by random chance. And so this is often denoted with the Greek letter alpha. To me, this is a silly example, but it looks kind of like a sideways fish. You're going to see it's also at the very top of the slide. You might see throughout these slides and throughout other resources, alpha is only denoted by that symbol, kind of like a sideways A. Significant levels or p-values is the probability of rejecting the null hypothesis when the null hypothesis is true. So p-values are inherently linked into the alpha levels, and we're going to talk about that a little bit further down. And like I was saying, type 1 and type 2 errors, these are very often completely mixed up, both in intro stats and by folks that have PhDs in this level. But this comes up quite often in power analyses. So a type 1 error is a false positive. I like to give the example, if you took a COVID test and you don't have COVID and it told you that you have a positive COVID test, that is what a type 1 error is. A type 2 error is a false negative. So you took a COVID test, it's like, nope, you're clear, you don't have COVID, but you actually have COVID and should not be going outside. And so those are inherently linked, and all of these analyses, you are dealing with how much you are comfortable accepting a type 1 error or a type 2 error with how strict you are setting your probabilities. This is probably the most tedious part of it because it's just set definitions. All right, so why are we doing this? What is the purpose of a power analysis? Power analyses can be run either a priori, which means before you run the analyses or before you collect the data, or it can be run post hoc, which means you've already collected the data. Generally, when we're collecting or running an a priori power analysis, we're trying to think about what resources we have, both in terms of money, time, participant availability, so on and so forth. One of the most common things that we look at is what sample size should I collect? We are social psychologists. How many participants do we need? If we're doing multi-level model, you might be like, how many stimuli do we need? How many schools do we need to collect from? Things like that. And so this comes up quite often in grant writing for you to justify how much money you're asking for. Post hoc is after the fact, you've already collected the data, you've already run your statistical analyses, you're trying to understand if you had null or significant results, how probable is this that it happened by chance? So let's say I did not find a significant difference between two groups. Is this because my study was not adequately powered, did not have enough people, was not sensitive enough to detect the differences between those two groups? Or is it there was genuinely no difference between those groups? And that's something that ends up a lot in results sections of papers. Any questions at this point? Cool. All right. So the main purpose, like we said, for a priori power analysis is to calculate the smallest sample size to reach the desired power. And so, why do we say the smallest sample sizes? It's because as academics, resources are tight. If we could just collect data from hundreds of thousands of people, we would all love to, but the funding simply doesn't exist for that, nor does the time or the resources. So, what is the smallest justifiable sample size you could do to adequately power your studies to detect the effects that most matter to you? This is also really important for gaining insights on p-values. Like we said, if you have a marginal p-value or non-significant p-value, is that because the study is not powered enough, or is it because there's actually no difference between the groups? And so lastly, these power analyses are also done so that you can minimize your chances of type 1 and type 2 errors, because nothing is worse than having to retract a paper for having a false positive or a false negative. So this is helping avoid those issues. Right. Power analysis versus sensitivity. You might come across when you're looking for resources on your own a sensitivity power analysis. This specific test allows you to understand the minimum effect size that a study was sensitive for at a certain level. So, when would you use this? It might be the case that okay, I have $1,000 that can reasonably pay 100 participants. So, how well powered is my study given these already existing constraints? What is the smallest effect size that I could plausibly see given the constraints that I already have around time, funding, and participant samples? The term sensitivity is the number of true positives out of the total of true positives and false negatives. So if you took 100 COVID tests and 85% of them said that you have COVID and the rest said that you did not have COVID, your sensitivity would be that proportion of 85 over 100. So assuming you have COVID. Um, Again, we're doing this to be best using our resources, time, money, participants, and also often research assistants as well. All right. One last piece on this is you can both over and underpower a study. Overpowering a study would mean that you have too many participants. You can detect super, super small effect sizes. And someone might be like, why on earth would that be a problem? Well, if I'm basing a thesis around there's a difference between these two groups, let's say an intervention to increase test scores, and the test scores are increasing from 85 to 86. Well, I just base my whole thesis on people very marginally increasing. There might be a statistical difference, but it's not super meaningful. And that happens more and more as you have larger and larger effect sizes. Overpowered studies, often people can get accused of fishing for resources if you just have thousands and thousands of participants, but the tests you're running really only require dozens. In terms of underpowering, that's what most people are worried about. You might have too few participants to detect a smaller effect size that is of interest to you. You might get a marginal p-value and be like, should I actually interpret these results? Should I not interpret these results? And I realize I'm throwing around the term marginal p-value. That's a p-value that's like right around the alpha that you set. It's so close to being significant. Should I interpret it? Or it's just barely significant. Should I interpret it? All right. So we want y'all to take a minute to brainstorm some times in which you would use a power analysis. So when is this going to be the most helpful in your research? Are you going to be using more a priori or post-hoc power analyses? What is going to apply the most in your day-to-day life? And we're going to ask a couple people to be brave and share their examples.
There's a variety of stages of the research process that this can apply to. So it's not only in those initial stages. So we have some examples. So if you're thinking of something other than in those initial a priori, that's exactly what we're looking for.
Yeah, of course. That's a fantastic question. So, for anyone who was not able to hear it, or the question was, does sample size refer only to the number of participants or also to the number of stimuli? So, if it's okay, I'll give a personal example. My lab studies faces. So, we might have a single participant, let's say Liz is in my study, she might rate 100 faces. And the power of the study, if we're doing a multi-level model, would be determined both by the number of participants as well as the number of stimuli. And there's slightly different analyses that happen. When we're doing power analyses for stimuli by participant interactions, we tend to do those in R, but they're a little loosey goosey for the technical term. You're trying really hard to get some exact numbers for things that are really speculatory. But this can certainly be referring to stimuli if you are perhaps like in biology, it might be the number of like test subjects, so like the number of livers that you have. We use participants most often because that's what's most relevant to us, but it can refer to any of those. And often they interact if you have both options. Loosely, the norm is more subjects or more stimuli is higher power. And that is golden rule that I've not yet seen to be disproven, but anyone else have any questions or want to share their examples? Otherwise, we can go through the examples we gave. Yeah. Hmm. Yes. Hmm. That's beautiful. So you're setting it up in the experimental like planning stage. You're looking at balancing both how many participants can you practically bring in and also how long can the study be that they have to read all of these. I will say for your research as it comes up in mine as well, if you need to quickly power something a little bit more strongly, upping the number of sentences, or in my case, faces, would have a stronger effect on the power than having more people. So doing a slightly longer study instead of having more people would power it a little bit more quickly. Mm.
We're going to be showing you some examples of the different like visualizations that the G Power program will give you as well. So we'll be showing you like how you can play around with moving just different pieces of the input numbers. So maybe the different amount of stimuli versus the different amount of participants and seeing how that will differently like give you different power results out of the G Power program.
So I'm going to go through this very quickly. It's similar to some of the things that we have discussed. Ooh, there we go. That we discussed earlier today, but a power analysis is relevant at any point in the planning process. It can be in the idea generating phase. When you're talking through theory, you might think about how complicated the statistical analysis you want to run. Like if you're doing a moderated mediation with 3 different moderated pathways, you're going to need a giant sample size to power that. If you know you don't have resources for that and you run the power analysis, that's when you might rework what type of study you're doing. It can also happen while you're collecting participants. If you realize you're losing a lot of participants for they're failing your manipulation checks, things like that. And then it also happens when you're pre-registering, when you're submitting grants, and often power analyses are put inside the manuscripts, both a priori or post hoc. Though which of those happens changes where it is in the manuscript. All right. So we already went through this briefly, but this is just a more concrete example of how things can be both overpowered and underpowered. So if there's large effects that are observed, it's a possibility that it could be due to random variation if there's too few people in the study. This would be underpowering a study. If there's too many variables that the researchers want to include in the study and they have a giant, giant sample size, you're very likely going to see a significant effect, even though it's really likely not meaningful. That's why the power analyses are important so that we can hit that sweet spot of where we should be putting our resources. All right. So now I'm going to pass it to Liz and we're going to talk through G Power in a little bit more specifics.
Okay, so now we'll begin, like she said, talking through with G-Power. And here I have the link to the website if you haven't already downloaded it, but you can also find this very simply by just Googling G-Power power analysis. It's open source to the point that it will be the first thing that pops up when you Google it. So this will be available, like Neela said, both in the slides that are posted and in other resources that we provided after this. So you'll be able to come back to this, but you can also access that now and go ahead and have it downloaded as we go through examples if that's helpful for your own learning styles. All right, jumping right into it. So when you first open G-Power, it's going to look like this. So it won't take up all of your screen. It'll take up about half of your computer screen, and we'll see at the top, right now we have just a blank screen. At the bottom, we have a middle row where it has things including test family. So if we look over to the top right, we'll be choosing from options like an exact test versus an F test versus a T test or Z test. We'll also choose things like the statistical test. So if you look at the bottom right here, you'll see like when we choose the T test menu, we can choose from these different options. So looking at the bottom left hand of the screen, we see that there's an input parameters and an output parameters section. So the input parameter section is the information that G-Power needs from you to then pop out information on that right-hand side of the output parameters. So we'll talk through this as we talk through examples, but just to orient you to what these screens look like, this is what we're looking at. So this is a slide that is a resource for you to come back to. This is not something that I'm going to be going through word for word, but overall, this is telling you that as you are using G-Power for your thing, you want to think about your research goals. Is this a priori? Is this post hoc? Think about how you're approaching the statistical test that you're choosing. The main thing I want you to take away from this slide is that you can approach this either using a distribution-based method or using a design-based approach. So the distribution-based method, this is when we as the researchers would select what test we want based on just going to the test family and thinking more about it of like, how are these groups distributed within my study? Thinking about it more methodologically. A design-based approach is when you have a specific statistical test in mind that you're wanting to run. I will say that on my own end, I typically am doing a design-based approach, but neither of these are wrong. These are two options that you can use. You can choose what statistical test you're planning on running, what statistical test you might choose to pre-register if you're using this distribution-based approach. So this is to say that neither are wrong and both are completely valuable choices to make. All right, so we're going to go through our first example here. So go ahead and just open G-Power and let's see if we're all looking at the similar thing here. So let's just think about a project where we're looking at if happiness differs by 2 years in school. So let's say we're looking at 11th versus 12th grade. We'd like to know if there are differences in happiness between these groups. So for this, we'd first choose the test family. So for this one, this is going to be a t-test because we're wanting to explore 2 different groups. Next, we'll be choosing the specific test analyses that we want to look at. So for this specific example, we see that we chose means different between 2 independent groups. So 2 groups here. Next, for type of power analysis, for this one, we'll choose a priori because we're thinking about our study beforehand. We're not running a post-hoc power analysis. And on the very right here, you see that I've indicated that this is a 2-tailed test. This is because in the specific example I gave, we're curious if there are differences between the groups, but we're not making a claim about which direction of the hypothesis that we're interested in. So it will change how many participants you need if you are having like a very specific hypothesis for a t-test versus a more general one. So these are all things to keep in mind depending on what statistical test you'll be using. Yeah.
Just throwing out there, the 1 versus 2-tailed will in fact change it quite drastically. And that decision is often decided by if you have a theoretical reason to only look at a 1-tailed. So if you have meta-analysis saying that 12th graders tend to be way happier than 11th graders because they're on their way out of high school, then you might do a 1-tailed. But that also means that you have 0 power to look at if 11th graders are happier than 12th graders. You can only detect it if 12th graders are happier than 11th and if there's no difference between them. which is why you'll have vastly different sample sizes based on one versus two-tailed. Two-tailed is always more conservative, is how we tend to say it. So it's harder to detect a two-tailed effect, but it's often the way that you want to run the analyses so that you can detect an effect in any type of direction. But that's a theory-driven piece.
Thank you. So let's say that we input all of these different parameters into this input parameters window here. What we're going to get is something that looks like what you have here on the right of the screen. So I've included that table from our definition slide just so that you can functionally see what we're actually going to be looking at. We've annotated this with arrows to talk through this. So looking here, we included an effect size. So again, the quantified size of the effect that we're going to be able to detect. Here we have our alpha level. We put 0.05. That is going to be what G-Power has automatically here. You are able to change this if you have like theoretical like research or statistical reasons to do so. But this is what the standard convention is. This is something that you do not have to change if you don't have reason to do so. We'll also put power. For us as social psychologists, a lot of times this will be either 0.8 or 0.95, but this can be very dependent on field. So if you're hearing us say 0.95 or 0.8 and your field uses something else, that is totally acceptable for still using this program. You'll just want to make sure that you change out what's in this convention here. All right, in this last box here, it says allocation ratio, N2 over N1. So this is a ratio of group size 1 over group size 2. So if group sizes are about equal, you can put 1 here. 1 is going to be what the standard is in G-Power unless you change it. But if you know that this is going to be something that's different within your study, of course, include that information here. All right, so after you've put in all of those input parameters, you'll click this calculate button that we've circled here. And what that will do is pop up what you see here on the right, which is the central and non-central distributions. This is a visualization that G-Power gives you, but it also gives you a wide variety of other information. So we'll talk through that. You can also see here on the right that on the bottom right hand, you see total sample size 210. So this is the simple takeaway, is that here in this analysis, based on the input parameters that we've provided G-Power, G-Power says that the total sample size that we will need to detect this power is 210. However, this isn't taking everything into consideration. We're going to touch base about why and when and how you might need to add additional participants to this number in your pre-registration, in your grant application, things like that. But that is where you find that base number. One thing that I find really helpful in G-Power is just clicking over from the central and non-central distribution button to the protocol of power analysis here up at the top. So the protocol of power analysis will give you a written out explanation of what input parameters you gave G-Power and what output parameters that it gave you in return. So I find this really helpful in my pre-registrations. When I pre-register things on like OSF, for example, I will copy and paste the G-Power result that I landed on, that I decided was the best fit for my study. I will include this exact copy and pasted output, and then I'll include the write-up, which we'll show you some examples of later. But I very simply copy and paste this. It includes all the information, and it's completely reproducible to anyone else who's using G-Power. Some other options. So you can also see here at the bottom X and Y plot for a range of values. So this will open up another side window called Power Plot. Through Power Plot, you can see that here on the right, it'll give you a drawn out plot upon pressing this button, and it can give you a visualization of how power is going to change based on how many participants you're choosing. So let me walk you through how to look through this a bit. So if we're looking at that bottom axis, says power, let's say that we were going for 0.7 power. If we follow that line up and then look over at the total sample size axis, we can see that this is about 100 participants. But let's say, oh, I have more resources than 100 participants. Maybe I can get a higher powered study for this. Let's see what it looks like if I wanted to explore like 0.95 power, for example. We can just go over here on the plot, follow that up, and see that that's 200 participants. So this can be a really functional way to think about power analysis, just giving that give and take of both resources, practicality, and what power that you're seeking for your specific field's goals.
I will also say that this exact plot here is something that's really good to share with collaborators, with if you have people overseeing the project, so that they can have a look at, okay, what is the so-called bang for my buck out of this. So when I work with my two advisors, I very literally give them this screenshot from this. I put the effect size on the y-axis, I put the effect size on the x-axis and participants on the y-axis, and it tells how powered we are. And that is exactly what I send to my advisors, where I'm like, here's what I recommend. What do you think? And then they tell me something entirely different. Because that's how working with collaborators always goes, is someone is going to have slightly different opinions in terms of power and sample size on that. So I highly recommend what Liz said of taking copy and paste from the other window for your pre-registration, but using this as your kind of go-to overview guide and for sending it to collaborators, because it's a pretty easy to read graph and pretty easy to move around should you need to.
Any questions at this point? Okay, great. We'll keep moving along. The next thing, or the last thing I wanted to show you specifically about this power plot too, is you can also play around with effect size directly from this window. So not only can you play around with visualizing the N count, so your total sample size versus the power that you're hoping to achieve, you can also change effect size from here. So if this visualization method is really speaking to you, if you feel like this is what you're going to be using in your own methods, just know that this is another option that you have here. Okay, so we're going to start getting into some more specific things about G-Power and what this like output actually looks like for different analyses and go through that. So we can begin that now. When we give G-Power these input parameters, it will give us output parameters. So this is going to include things like that power plot I just showed you. It'll give you that protocol info that you can copy and paste and send directly to either collaborators or include in pre-registrations. It'll of course give you the N, so the total sample size that it's giving you before additional considerations. And it'll also give you a table. So let's see what that looks like. For example, here's where we'll find the N after pressing calculate. This is what one of the graphs will look like. This will be the main one that pops up at the top of the G-Power window. We have an example like explanation here, but that's mainly just here so that if you're coming back to this resource, you don't have to remember every word that we've said out loud. So as far as the protocol window goes, again, you can access and review that through the protocol tab. But aside from that, here's just a resource for you to remember how to get back to this. Some final notes on understanding the output of the power plot. So again, this is a visual summary of how power, sample size, and effect size all coexist within this parameters within G-Power. So showing how the probability of detecting a significant effect, it changes depending on like what you're actually trying to get magnitude-wise in your study. So this is going to depend on things like your sample size that you're able to achieve, but also alpha levels. And we showed you the differentiation between X and Y axis, but again, as a resource here, if you're coming back to these materials. So let's say that visualization method was just not exact enough for you. And that might be the case. I know a lot of us academics just want that exact number. I don't want to just follow up a dot on a power plot and hope for the best. So if we go from graph to this table option here, it will give us exactly that. All of those individual points that we saw on the power plot, it will put it out here into a table. So this might be a more standard convention of presenting this information in your field. Might also be what your collaborators prefer. It might be better for the pre-registration template that you use. There's a lot of reasons. It might just be your preference, but you have the option to use all of these within the same program. Yes, Neela just reminded me that the nice thing about this table is that sometimes word counts in journals, it is not like all the words. So sometimes like tables don't count towards word counts, or sometimes like graphs don't count as word counts. So sometimes you just need to show the exact same information in other ways so that you can include more like content sentences in other places of your paper. So that's another way that this can be really practical for you. All right, so this is just a summary of the different strengths and limitations. Not to say that either of them is like the better or worse choice. There's just different pros and cons that are nice to be aware of. So feel free to refer back to this if it's helpful. The main takeaway that we want you to have from this is that the graph is just telling you about overall trends, overall relationship, and it's more qualitative. It's great for understanding big picture things about what G power is giving you as an output. But the table is about those exact numbers, and it's way more detailed. So that is a more quantitative measure, and it's ideal for reporting or making additional calculations based off of those numbers. Okay, so now I'm going to show you a few different slides, so I'll orient you to what we're looking at here. So for each of these examples, we have the title in the top left. So what sort of drop-down statistical test are we looking at here? On the left here, we see what the output menu is actually going to look like. The reason I put this here is that the input parameters that G-Power asks you for, it depends on what those initial drop-down choices that you make are. So t-test has just these few, or this right now I have a correlation test up here. So there's just a few input parameters that you'll need to input here. If we get into more complex analyses like linear regression, some hierarchical modeling, or MANOVAs, for example, it's going to request more information than this. So you'll see that as we go along. We've included the relevant definitions here so that whenever you're running each test, you can see which definitions are just going to be relevant to what you're looking at. And in many of these cases, I've been able to find like point and click YouTube videos for this specific kind of analyses. So if that is helpful for you, as like if that follows your learning style more, definitely feel free to either reach out to us for these slides or find these materials online, and then you can access this as well. All right, so here's an example of the t-test correlation one. So this one is for point by serial model. For this, even as us who are experts in using these materials, this program specifically, we are always referring back to these sorts of materials when we are doing it like G-Power power analysis ourselves. This is not something that you nor we are expecting ourselves to like memorize all this and be able to like open G-Power each and every time without having to look at a resource. Before we made this resource, that just happened to be things like textbooks and various academic websites, different websites from university campus, things like the Social Science Research Commons. But we've collaborated these all into this one document, so I won't be going through each of these, like exactly what is on each of these screens, but I will show you what all resources we've included in this.
One other resource that you might want to look into, G-Power themselves has a manual. The reason why we created this instead of just referring you to the manual and setting you loose is that manual is hundreds of pages long, I believe, and does not always use the exact same terminology for how they're referencing ANOVAs, how they're referencing certain things. I've tried, using Control F for the certain type of the analyses, or how do I do an a priori analysis for correlations, and it just doesn't come up super easily using that resource. That's why we wanted to compile this from all the resources that we've seen across the internet so that you can refer back to it in one consolidated place, because the G-Power manual is so detailed to the point where it becomes a little bit difficult to use.
Okay, so one of the things that you can see here that it's going to request from us as an input parameter in order to give us this output is specifically effect size. So this is a great opportunity to talk about that G-Power is going to constantly ask you for information that you do not have what we as academics would consider like a scientific, solidly backed answer to. So for example, here, effect size, it could be drawn from things like previous literature or a pilot study in your lab, a previous study, or a subset of the anticipated sample. But what if you don't have that information? What if this is your pilot study? What if you were trying to pilot your your pilot study? Or what if this is such a novel idea that there is not anything in the literature that is a substantiated reason to include like that effect size in your G-Power calculation? So this is where we're getting to things that are really just going to come down to conventions. So I've included some effect size conventions specifically that we're familiar with from social psychology. So they differ between which sort of statistical test you're doing, and they've been categorized into groups of small, medium, and large. So when this comes up in our studies, we would refer to a table like this, and we would just use a convention. So that is using like this table came from a journal article. That resource is available here. So this is something that is citable. But you're just not going to be able to have something in all situations in practicality where there's always data that you have your hands on that you are able to analyze and get an effect size from. So it's very normal standard practice to have to use conventions within G-power analysis. So something to be prepared for, and we'll show you this as it comes up through the examples. So here's one for ANOVA with fixed effects, specifically a one-way ANOVA. And already this is our second instance of needing information that very well could be unknown given like what specific study you're doing. So this one is requesting standard deviation. Again, this can come from something like a pilot study, a previous study, a subset of your anticipated sample if you're not doing like a standard pre-registration. Maybe there's not a meta-analysis on this that is available based on these specific variables. So what do we do in this case? Again, this is just going to be an instance of using conventions. There is many times where the best you can do is just use these conventions and hypothesize with theory. And we recognize that that is like an incredibly frustrating feature of doing power analysis, but that is part of just using it, and it is part of making statistical decisions within your own research. So we also have one for an ANOVA with main effects and interactions. You see that these options in the input parameters do differ slightly. So it's asking different information from you because in the end, the sample size that G-Power will tell you, it does differ between an ANOVA one way and an ANOVA with main effects versus interactions. ANOVA with repeated measures between factors. Again, not talking through all of these individually because you will have all of this as a resource to you. MANOVA, you can see here that the types of questions in the input parameters begin to change. We see things like number of groups, where of course a t-test isn't going to ask you that question because there are only the two groups there.
All right, so any questions for Liz on some of the exact ways that we can use G-Power before we move into what do we do with these numbers that we just got from the output? Yeah.
Good question. So there is linear regression like as an option within G-Power. So that is one that hasn't like reached the level of complexity that G-Power can't handle it. There are resources in here for that, but they do get more higher level, specifically for things like hierarchical modeling. Not super convenient in G-Power. That might be a case where we'll touch on this. At the consulting center that we work at, we have access to some more higher powered power analysis like programs, and sometimes it is just a better option than G-Power. For linear regression, though, there are examples here, but for the sake of a beginner's course, we just stuck to like ANOVAs and t-tests just to get that introduction out there. But definitely available and included in the slides.
I think it's one of the drop-down menu options. Yeah. Mm-hmm.
Here, I'm going to go ahead and give you this so the folks on the Zoom can hear us also.
So I work on like information systems related topics, and I do a lot of A/B tests between like different AI agents to people. So because of that nature of experiment, I do struggle with a lot of hierarchical data because of the repeated measures. So I was wondering, like, you just advise us like not to use G-Power in terms of like hierarchical data. So do you recommend other software like R and some kind of open sources for that? Yeah.
Yeah, so for hierarchical, so repeated measures, similar to the linguistics question, we tend to default to R. Pass can also do this. I will say Pass is a very expensive option for folks to buy it lab to lab. It's something that we've accessed through the statistical consulting center, and there's folks that are specifically training themselves on that software to be able to help people with grant writing and so on and so forth. That is one option. There is also options to do that in R. Often when it comes to hierarchical repeated measures, folks go to modeling options for their power analyses, and it'll get a little bit more complicated. There's also papers that have run, or sorry, simulations rather than models. They run simulations for those power analyses. There are papers that you can refer to that will give you some benchmarks. So I know in my field, when they're using social stimuli, so different faces, we use a paper by Westphal et al. That I can find that should be applicable to things like sentences and similar to how they are being applied to your research as well. So I would dig into some of those statistical papers for their modeling so that you don't have to run it on your own, or you can come to us and we can also run the modeling for you. But often that is done in our pass just because the point and clicks can only get you so far in G-Power because they're trying to balance user-friendly versus powerful for those. PASS.
We'll go ahead and jump down to these slides, and we'll come back to wording suggestion because I can tell that it's relevant to a lot of the questions that we have. So there are lots of times when power analysis will be more complicated than G-Power will be helpful for. And in those cases, it's going to be something like you don't have the information you need, or it, like you're saying, G-Power is just not well suited for all of these things, particularly more complex analyses or cases that we need to look at simulations. But that consulting center that me and Neela are both coming here through, we offer 1 free hour to both grad students and faculty here. So if you need help on a single power analysis, you can come to us and just get that 1 free hour of help without moving forward into like billable work. We're happy to help you. But beyond that, let's say that you really needed a complicated power analysis as the basis of like a dissertation or another project. If it is dissertation specific, it looks like it's getting cut off on some of these screens here, but dissertation students can have up to 10 free hours of consulting help from us, and that includes accessing this past software. We will access it for you. We can do it on a Zoom meeting. We can meet you in person on the lab that this like program is available on. It is so expensive that we have it on like one physical computer on campus. But so for dissertation students, up to 10 hours, all you need to do is send us information that we can connect with your advisor to make sure that it's okay with them that you are getting statistical help. But we can tell you from our experience as consultants that you would not be the first PhD student to come to us for help on that sort of thing.
Pass also has a free trial that I believe limits by function rather than time. So you can run, I think, X number of tests with X number of like some amount of complexity, but it limits the types of tests and how complex you can get. It might limit the number of tests, but if you just need a quick answer and what you need falls under that, Pass is also a point and click option like G-Power that you might be able to just use the free trial on.
So I'll like quickly summarize this for you just so that you understand like what resources we can be here for you after this like workshop is done. So everyone who is an IU affiliate can get 1 free hour of help. And the hint that I've included here at the bottom, you can be very open with us as the consultants and say, do not go over an hour. I do not want to pay. I only want to receive this free help. If we don't achieve my goal, let's have that conversation then. But many times with a variety of clients, we are able to answer these sorts of questions within that single hour. So please do keep that in mind. Yeah, super good point. So we have like an intake form that the link is available on here. You can also find us just by searching Indiana Statistical Consulting Center. In that form and in our initial emails back and forth, the more information that you include, the better, especially if you're trying to get your money's worth out of that 1 free hour before like approaching billing things. So throw information at us. You can tell us that you don't want to go over that hour, and we will do what we can with that hour to help you. And then we can touch base there to see how we want to move forward. Does anyone have any questions about like how we can help after this? Cool. Okay, well then we'll jump back into the wording suggestions, and then we just have some examples for you guys.
Try and click back. Reverse, reverse. Okay, so we include these slides for ran something in G power, ran something in R. What do I do with this number? How do I communicate it to others? Like in most other statistical tests, the exact phrasing of how you say things is going to vastly change how it's interpreted and how it's meant. So, like many of my stats professors have done for me, we gave exact wording templates that you can just plug the numbers in. A lot of power analyses are like any other equation you have, you're just adding in the pieces that you have and solving for x and what is whatever is left over. So, wording suggestions, you might say something like based on G power analysis, and it is very common to list the software that you use to run the power analysis because they all use slightly different mechanisms. So, based on a G power analysis, a minimal sample size of blank participants is required to detect a medium effect size with blank power. I will also add that it's normal to say how you define a medium effect size, because again, that will change by test and it will also change by field. So you might say a minimum sample size of blank was required to detect a medium sample size, parentheses, what you mean by that, with blank power. You also might say something like 200 participants will be sought for an end goal of 180 participants per condition after exclusion, 200 participants in total. So why do we say this with exclusion? So G power might say that you need 90 people per condition, so you need 180 people total. As researchers, we know that not all data is good data. Some people might join your survey and leave. Some people might fail manipulation checks. We have people rating faces. They might rate every face as 1, and that's not actually meaningful data. So we're assuming that you're going to be dropping some participants based on some predetermined criteria that you've set, which is often included in a pre-registration. So how much data you're going to need to drop is going to depend on how your data collection method is set up, where you're collecting your data from, how long your data collection method is going on, and also field level norms. So I collect data online. I drop a whole lot less SONA undergrad participants than I do MTurk participants, and I drop a whole lot more MTurk participants than I do prolific participants because I get different qualities of data from those. But I always set the rules of how many participants I'm going to drop ahead of time. We tend to oversample by around 10-ish%. That is a complete ballpark. Usually we tend to go to the largest next number. So if we collect 400 participants, we tend to up it to like 450 or so. But that is going to differ based on your resources, based on your norms. And you can also look at papers in your field for their exclusion criteria to refer to those by and kind of calculate the attrition of the data there. It is always important when you're talking about your power analysis to talk about both what the software told you that you need to collect, so what your minimum is. G power said 180 participants, but also how much you're oversampling. G power said 180 participants, we're going to collect 210, assuming that we're going to drop folks. And it's okay if these are slightly off, but again, we want to be careful to not over or underpower our studies. Any questions there? We could have a whole separate workshop about excluding participants. So for sensitivity-specific power analysis, we have the example of, given the sample that I've already obtained under X restrictions, so given the restrictions I had to collect 100 participants from prolific and the test that I plan to run, so I would substitute that with their specific test. Given the sample I've obtained under the restrictions of 100 free participants from prolific, and the t-test that I plan to run, the smallest effect size that I can detect with blank power is, and then insert that D statistic. This is an important time to note that when you're reporting these statistics, it's generally in APA format, so you're usually going to have a lowercase letter that is italicized. Small detail, but some folks will get very, very picky about those things. So now we want y'all just to take a second to create a template based on some of what we have so that you can take it away for how it is going to be applicable to your specific research. So if you can think of a project that you're working on right now, what test are you running? Are you doing it a priori versus post hoc? And fill in those blanks for yourself so you can just plug the numbers in as you have them later on. So it'd also be a good time if there's questions while folks are working on that. Okay, I'm starting to see the slowing down of writing. So we wanted to put this in there so that there's time set aside for you to double check these things as you want it so that you can run it by us before you run out the door. You can practice it with the examples that we'll do later, things like that, so that you have a version of it that you're comfortable working with for your own work later. All right, so we're going to skip to some examples, I believe. We moved the order around a touch. All right, summary.
So, just to give you a quick overview of all of this information that we've thrown at you, anticipate needing to exclude missing and sufficient data. Yes, G-Power is very helpful in many ways. Power analysis is a required step of the research process, but anticipate that you're going to need more than what this calculation can give you. It's a computer, it's doing like a statistical equation. It's not thinking about if you're going to have participant attrition or if people aren't going to be giving you good data. Yeah. Sometimes power analysis requires information that is not available. And that is part of power analysis, particularly if you're studying something that's more like up and coming, a bit more novel, or if it's new to your specific lab and you don't have access to pilot data. It is normal and okay to look back at references and guidelines when completing power analysis. I told you that that's the case for both of us when we're running power analysis. It's knowing enough about it so that you know what resources are helpful and being able to get that information out of it. And now that you have this resource, this may be the one that you choose to come back to. And just as a reminder, everyone, grad students, faculty, anyone affiliated with IU can get 1 free hour of stats help from ISCC. All that information is included in the PowerPoint. You can also feel free to reach out to us directly. And if you're a dissertation student, there is this great opportunity for 10 hours of funding from Dean Delacque. So definitely feel free to make the most of that if you're able to. And as this graphic depicts, this is really like a process of continuously revisiting power analysis throughout the research process. So expect that and know that it's okay when that happens. So I'm going to give you a quick orientation just to what other resources I have within here. So feel free to come back to this. We're not going to play through these, but you may find them helpful both like as we go through examples, but also just as you're coming back and doing this for your own work. So I included some like visual reviews of like what's actually going on for those definitions. So like if that first few slides felt really dense to you, maybe those were words that you're not super familiar with or used to working with, you may feel like going back to a YouTube video is something that fits your learning style. I love finding YouTube videos for different concepts, and stats is definitely one of those areas. So we also have one on like what even is statistical power. We keep throwing around that word a lot, and it's not always touched on super clearly in stats classes. So if that's you, we have a resource for that. We have some other videos just on like simply definitions. I also found some open source PowerPoints from like university and statistical hosted areas that include a lot of the same information, but with different depictions, different wording, different recordings. So if you want to look at some other like academically hosted resources, those are all within this one slide. And then Neela was pointing out how like the G-Power manual can be both helpful and lesser helpful in some ways. We have that resource here for you, so you can find out for yourself if that's the way that is going to be your preference when you're going through G-Power. There's also guides from others. I've included that here. And there's also specifically been guides made for things like effect sizes, confidence intervals, and just other manuals and guides. additional references if you would like to get into the nitty-gritty of reading an article on this. If you're unfamiliar with stats journal articles, this may not be the one for you because they are they are dense and there are a lot of equations that, quite frankly, you may not feel like you need to know to actually utilize this within your own research. Okay, so that brings us to doing some practical problems. Does anyone have any questions that we can touch base on before getting into an example?
I do want to throw out before we dig too much into the examples, like Liz said, a lot of the information that you will be putting into G-Power is not always readily available information. What type of effect size are you expecting is often an educated guess. What the standard deviation that you're expecting is often an educated guess. So often these are ballparks that you're working with. So do I need 45 participants or 4,000 participants? Is this a feasible question or not? Is often one of those things that you're going to answer with the power analysis. I will say power analyses become more and more reliable the more that it's based on previous data. So if you're replicating a study that you've already run and you have those effect sizes, you have those standard deviations, you can plug them into G-Power, that's a really, really reliable power analysis that you can trust deeply. When you are doing entirely exploratory and you're like, I think the effect size is going to be like 0.5 to 0.2, then you're creating ranges for yourself for how comfortable you are. And I highly, highly, highly recommend presenting them as ranges, bless you, both in text and to collaborators. We're expecting an effect size of this for insert theoretical reason, insert theoretical reasons for all of your justifications there. So we think of power range between X and Y, therefore we're sampled up to X number. It's always good to throw a range in there if you are not super comfortable with the exact number, especially because in highly exploratory studies, many of the inputs that you're putting in are based on hunches and guesses from previous work that's only loosely related to yours. And this becomes more and more true when you're doing simulations and more complex analyses that are often not well explored.
All right, we will go ahead and jump into our first example then. So if you chose to have G-Power downloaded, go ahead and get that open and just start from just a blank opening window. So I'll set the scene for us so that we can all work on the same example problem together. So consider you're doing a pre-registration where you're going to be running a study where you want participants to tell you how much they support a new government policy, and it's going to be a continuous outcome measure. So you could also consider this as comparing whether support differs between respondents from two cities, for example. So before accounting for these things that we talked about that were additional considerations, so like data exclusions, things like that, what is the minimum N according to G-Power that we would need for both a 0.05 alpha level in order to seek 0.95 power? So we're going to go ahead and walk around to be able to help you guys with any questions that you might have on this, but feel free to try to work through it on your own. Feel free to look at any of these resources that we've included and raise your hand when our help would be helpful, and we'll just come around. We will also be providing the answer on the next screen, so you will not be left out to dry if your preference is not for us to come over and help you individually.
I will say we have 4 examples up here. So if you finish through the example and you're ready for us to move on, you can shoot us a thumbs up, make eye contact. Folks on Zoom can private message us as that they're done, whatever works best for you if you like to see some of the other examples that may or may not be closer to your own research questions. While y'all are working, we got a question in the chat, which is how would this work with moderation, mediation, structural equation modeling? Do we need separate power analysis for each regression within the model? Um, do we need some ratio of sample per parameter, etc.? So for structural equation modeling, I would do simulations. This is often done in R, and G-Power simply can't do it. And that is going to be dependent on how many parameters you have and how correlated they are. So I would run simulations based on those unless you can find a paper that has already run those simulations for that. For simple mediation and moderation, there are also papers that have conventions. So if you single X variable, single moderator, single outcome variable for mediation, there are conventions. I believe the convention for that is usually around 300. Moderation, you can usually do a little bit less. But when you start getting into much more complicated ones, I think simulations is again the norm for doing so. But often folks are just trying to sample as high as they can when they get into, for example, moderated mediation with multiple moderators. And so either simulation or doing as much as you can. There's also rules of thumb for ANOVAs, for example, which is not mediation and moderation, that folks like to do for social psychology, which is like 100 folks per group. But this is not, I tried very hard. I could not find something to cite for that. So you can often find rules of thumb. You can also justify these with, if you think you're going to have similar effects, you can find another paper that's running the same model and you think you're going to have similar-ish effect sizes, you can say something like, following the sample size of so and so et al., we're going to collect a similar sample size. So you can often justify it by another paper instead of running the power analysis exactly for some of the more complex models.
If you're someone like me who pre-registers a lot of your studies, you may be hearing that and just thinking like, so am I just supposed to cite like an article that did something similar in my like OSF? And this is kind of an interesting point in like open science history where like there's really not like regulations, rules, frameworks on pre-registration. Like we're all just kind of in this together trying to follow the rules, like for those of us who just have kind of the interest in it. It's not even a requirement for many of the journals, many of the outlets that we're going for. So the honest answer is that sometimes you're just, when it comes to like putting it on a pre-registration, it's trying to fit best with what your outlet is going to want to see. So hopefully like it's nice when you're able to just say like, oh, here's a paper, so I have a citation. But just quite frankly, with how like new pre-registration is, that might not be something that's there, and you just have to do your best of wording it.
I will also say, if you have absolutely no clue on sample size and you did a power analysis and you're kind of running with your best guess, that's when you do the post hoc power analysis. And like, okay, we have this amount of power to detect a sample. sample or to detect an effect. And that's when you can report that in your results section. And if you're in a field that has multiple studies per paper, then you use that information in your A priori for study 2. It's fairly normal in some of our fields to not pre-register, not power analysis the first study, and then do a really in-depth power analysis for study 2 once we have an understanding of what the effects we're looking at and have theoretical backing for what we're doing.
Good question.
Are folks ready for us to give the answer for example 1?
Okay, so just as a reminder, our example was thinking about, are there group differences in policy support on a continuous outcome measure? So looking here, you can see that we chose two tails. We did not have a directional hypothesis in this case. For an effect size, we have a medium effect size 0.5. That'll be what's automatically in there. And we have 0.05 of the alpha, power 0.95, just as we shown on the last screen. And we did not say that we had any theoretical reasons to change this allocation ratio, so we just left that as 1 here. We can see that it gives us an equal sample size across groups, 105 participants for each groups. And it's also giving the overall sample size of 210. So again, this is not including any of those additional considerations that we went through, but this is one of the numbers that you will want to cite in your write-up, or that will be included when you copy and paste that protocol information. Okay, so, oh yeah. So that was just a convention that'll likely be what was automatically just popping up in G-Power. So when we don't have a theoretical reason to change that, in this case, we didn't in like our little write-up, so we just kept it as the convention. If you were doing a study on this exact same topic and you had a theoretical or like literature review backed reason to do like higher, lower, you would absolutely put that in there. Thank you. What other questions can we answer about this first one? Okay, so let's just slightly change up the output of what we were just looking at. So let's say that we were doing a follow-up replication study. Like Neela said, that first study was a bit more exploratory. Let's move on to a study 2, and this time let's have a directional one-tailed study. So we'll go ahead and change that drop-down menu from a two-tailed test to a one-tailed test. And we can see that that number changed from a total sample size of 210 here for the two-tailed test. Again, sample size of 210. Now a sample size of 176. So like Neela was saying, the more directional of a hypothesis that you have, the less of a sample size you need. The two-sample t-test is more like noise within the study. You'll need more participants to actually rule out that example.
I will also say, following up on your question, since this would be a follow-up study, I would use the exact d-value, the exact effect size that you would have gotten in study 1, and you put that into the input for study 2. So study 1, we think a ballpark medium effect size, we use the convention of 0.5. Study 2, we have study 1's data. Let's plug study 1's effect size in here, and you'd have that exact measure. It might be, 0.52.
All right. So we'll go ahead and up the complexity of this a bit. Let's say that we were looking at 4 groups instead of just 2 groups. So this should already go ahead and flag for you that we're going to be changing those first initial drop-down windows from t-test to an ANOVA, a 4-group ANOVA. So let's assume together that we have an effect size F of 0.25. And let's determine the sample size according to G-Power for rejecting the null hypothesis at an alpha level of 0.05. Again, we'll just do this 95% power. We'll give you guys like 1 or 2 minutes to go through this, and then we can show you how to do it. Feel free to raise your hand or throw a question in the chat in the meantime. Okay, so I see us all slowing down. It might be possible that this one we're really getting the hang of it. So that's great news. Let's go ahead and see what the output is and see if we all got it. So for the test family, I went ahead and changed it to an F test. The statistical test we have as an ANOVA, fixed effects, omnibus, one way. Again, we're keeping it a priori, and we've inputted those input parameters that I had on the previous screen. Over here in the output parameters, we can see that now the sample size is 280 for the specific question. So between groups, let's see, that would be about 70 per group before data exclusions.
There are also ways in some of the ANOVA tables, if you are doing moderation with two binary variables as the x variables, to use G power for moderation as well. I just remembered that. But that would be specific cases of moderation if you have x1 being yes, no, x2 being old, young, for example, two binary, couple binary variables, because you're messing around with the groups in here. But again, for mediation, it would be another point. Just wanted to throw that out there.
All right, we'll go ahead and go through our last example, and then we can just use these final few minutes to answer any lingering questions you guys have, any questions you have about reaching out to us and getting in contact for that free available help. All right, so last example is, what if we explore the role of age as a continuous variable? So now we're getting into regression area. We're going to be just doing a G power for a simple regression here. So let's assume a small effect size. We'll do 0.15 here. It will be a simple regression, like I said, and let's go with a power of 0.8, just so that we get used to changing some more of those input parameters. And let's pretend that we want to determine the sample size to be able to reject at an alpha of 0.05. We'll give you a minute or two. All right, guys, let's go ahead and reveal the answer to this last one. So now the test family is F test. We have the statistical test as a linear multiple regression, a fixed model. Specifically, we're looking at R squared deviation from 0. So when we start getting into more complex analyses, so like the differences between these ANOVA options, the differences between these linear regression options, my best suggestion here is to refer back to the G power menu for these. There are such small distinctions here, and it may not be phrases that are conventional in your field. I know that for our sake, these are not like words that we are used to using within our statistics. So the G power menu can be really helpful. The good thing is that a lot of us kind of run the same analyses on our research over and over again. So once you get that answer for yourself, you're going to have it. But I do want to acknowledge that it's not super clear why this would be the linear regression that we choose, but it is in fact the one that we choose here. So here we have, we'll just enter our number of predictors, alpha error prob. And here we didn't have the example go all the way through here on this picture, but go ahead and get the output that you get from putting these parameters in. For the number of predictors, you'll just have one because we're just looking at one predictor, age in this case, and see if you get the same output. The real practice is going to be on the next slide for this example. So just see if you can get to this point. Yeah. All right. Great. I'm seeing some head nodding. I'm glad that we're getting the hang of this. So I put up this wording practice again. This will be the last thing we practice. Feel free to go ahead and use one of these examples or that own template that you made. Just see if you understand like where you're going to pull this information from to put it in that wording example. And then we're happy to answer any questions that you guys have. All right, folks on the Zoom, I haven't gotten a question on here in a while. I'm curious if anyone has any lingering questions. You can feel free to throw it in here and we can address it as well. All right. Well, thank you all for coming here. We'll go ahead and put our names back on the top of here so that you know who we both are if you weren't able to join us right away in the first few minutes. You can find us on the Indiana Statistical Consulting Center website. I'll also have us put both of our emails into the chat here. If you're in person, feel free to come up to us and we can give you our email. But feel free to reach out to us, whether that be for questions about this workshop or for getting in touch with some statistical help with either us or one of the other consultants on our team.